Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. So in this video we're going to look at a customer return saying it wasn't working properly and the temperature was running away and doing all kinds of bad things. It popped GFCI and some other stuff. And anyway, so he sent it to me, and I first thing I noticed, and I've already started looking at this, and I decided to go ahead and just roll some video on this, just to let other people see what's going on. I'm not going to tell you who the user was. I'm not going to throw anyone under the bus. And by the way, if anything like this ever happens, oh, sorry about that. If anything like this ever happens and, you accidentally, do something that causes something like this to melt down, then, you don't have to hide anything. You just send it to me. I have not yet ever charged anyone for repairing a controller. So, whether it's, the user's fault or my fault, right? So, anyway, when I first got it back, I could smell that the magic smoke had been let out of something. And the first thing I noticed was this right here. And this is, sorry, I'm doing this upside down and backwards. But, so you can see this arced against something. And this little tab right here is hot, by the way. And this, as you can tell, red is the auger. So something inside the grill touched against this that was connected to ground or some kind of ground. I'm guessing ground. He said it popped the GFCI. Anyway, so it let's see if we can get a better look at it. Anyway, so yeah, he said the temperature was going crazy. Since this is the auger controlled triac, I'm guessing that it probably got stuck on or something. I haven't actually tested it. I don't really care what happened to the triac, but I'm guessing it's bad now. And anyway, something arced against this to ground, and it smoked this resistor right there. And I'm like, yeah, no big deal. I was kind of surprised it burned it so bad, and I already pulled the resistor off, and I thought it just burnt this resistor and this, and I was just going to replace the resistor and go on about my way. And then I noticed something curious. I saw a little burn mark in this wire. And now that got me to scratching my head. I'm like, wow, if it got, maybe this wire was close to this resistor or something like that. Maybe that's what burned it. But I started looking I was like, okay, so we've got two things that are burnt. And I started looking around, and look at that. Now this concerns me. That I would have expected this fuse to have popped before this happened. And so these are 5 amp slow blow fuses, and this board is rated for 5 amps. I'm guessing these little fuses are not. The little resistors are. I forget how many watts they are, but I'm going to have to revisit that. But anyway, it should have popped this fuse before it did this. This is not good. So I'm going to revisit these fuses. I might send them out to the other users. Anyway, it's okay. I'm just going to have to replace this board. But the key point I want to make is you've got to keep any kind of metal conductor away from this whole back high voltage board, okay? Everything on here, let me zoom out a little bit. Everything on here is high voltage. All these triacs, all these caps, all these resistors, the fuse, everything on here is high voltage, and if you touch anything to these tabs, these triac tabs, which are live, you're gonna do this. Hopefully it won't do that again. I've never actually purposely shorted it out to see what would happen. I have popped a fuse before. I forget what I did. anyway, I've blown a fuse, so I'm not exactly sure why this fuse didn't blow. I was looking at the spec for this fuse, and it'll allow momentary current up to like 50 amps. And so this might have just all happened and before this guy had a chance to pop. So I might go ahead and change it. He's a slow blow. I might change him out to a fast blow that'll prevent this from ever happening again. Because it's better to change the fuse out than it is to replace this board, right? But anyway, I wanted to show you that yeah, so this guy right here is just absolutely fried. Let me get zoomed back in here. So yeah, and this is, I haven't looked at the schematic to see where this guy is, but yeah, these little fuses, I keep saying fuse, these are MELF resistors. These little MELF resistors apparently don't handle 50 amps very well, or whatever this thing was pulling to generate this kind of heat. I think that's the only thing that's burnt on here. So yeah, I'm going to have to pull this board off right here, and I'm just going to toss it. Yeah, there's no sense in trying to rework this. It's burnt all the way into the F4 PCB material, so yeah, that's it's just trash. Yeah, I thought originally I was just going to be able to pull this triac off and then put another resistor on here until I got a better look at it. So anyway, I'm going to take some of these wires off. Yeah, another thing too that I noticed. So this guy had a Z-grill, and I'm guessing that it's really cramped inside there, because you can see right here that this wire right here was grinding up against something, and it's almost, let's see, zoom in. I'm trying to do this through the camera. Yeah, not quite, but it wouldn't have been too much longer before that shorted out. And there was another one in here. One there. And there. Where is it? I saw it earlier. There was like two of them. One of them was pretty bad. Oh, here it is. It's this orange. What is that? The fan? Yeah, so the fan. And you can start seeing the wire in there. Let's see if you can see it. Can you see the wire? If I get it right in the light, you can start seeing the wire poking out. So if something wouldn't have shorted on this triac right here, it was fixing to short out right here. So we, this is not good. If you've got a Z-grill and it's real tight, you need to watch Adam Proctor's video. I'll put a link in for it on how to install these controllers in a Z-grill, because yeah, this is not good. I mean, I think he only ran this controller. This was his maiden voyage, and all this happened, right? But you can see it was just grinding away. So this is the black wire. This is a power in wire. Is grinding on. It's grinding on the red wire, which is the auger, and it was grinding on the orange wire, which I believe is a fan. I don't remember. Yeah. So yeah, watch Adam's video on how to tie these wires up and store them. So yeah, because yeah, that's not good. We're gonna have all kinds of problems if that shorts out. I mean, if it grinds through that. So yeah, I'm just gonna cut these guys off here. Sorry, you guys can't see what I'm doing, can you? All right, that's out of the way. I want to keep, now I just go ahead and cut these guys off. I'll just put new ones on. Yeah, by the way, if you're wondering what this blob of stuff is, I know it looks a bit how you doing, but it's just basically to hold these wires from flopping around. I mean, I don't have to put that on there. I could just leave it, flapping around in the breeze, but I didn't want people to kind of get it hung on something and pull on it. So I just kind of, this is some some electronics grade silicone. And yeah, I know it looks a bit crappy. Sorry about that, but it is what it is, and does a good job. So yeah, okay. Yeah, next we need to clip these caps off. And by the way, this video is going to cover quite a bit. People ask all the time about this internal antenna. So this has an internal antenna on it, right? And people are always asking, oh, how easy it is to replace an internal antenna. Well, it's not easy, because I basically have to pull this high voltage board off to get this ESP32 module out that is basically glued in place. And I do this, I like I said, I know it looks a bit how you doing with silicone grade the electronics grade RTV. But I do this for a couple reasons. This is the top of the controller. If any water drips down in here, it's not going to go across these the control pins for the controller. It's just going to drip down the side right here. And there's also conformal coating on this. I don't know if you can see it. You can see that shiny gloss on there. That's conformal coating. That's like a layer of clear lacquer, for lack of a better word, that basically, you know, seals the electronics, so dust and dirt and water get on here. I mean, you can't soak it in water, right? And obviously, you can still short things out if you touch them. Because this conformal coating is designed to where you can service it if the product comes back, right? And so you can scrape through it. I guess I could do. Yeah, so you can kind of scrape it off and then just reapply it when you're done servicing it. All right. So let me see here. Go ahead and finish what I'm doing. Just get a little bit sidetracked there with. Let's see. I might as well just take them all off. This board is trashed. Yeah, I'd like to salvage these things. These caps cost about $3.50 each. But yeah, I'd have to unsolder them. They wouldn't be real long. And the V4 they won't fit on the V4. So let's go ahead and take all this guy off. So anyway, back to the external antenna. I don't think I finished my story. If I had to put an external antenna on this, I'd basically have to pull this board off so I can get this ESP32 out of here. And so this is kind of this is what I'd have to do. I basically have to replace this whole high voltage board. I'm guessing. I've never actually tried. I might be able to get my solder sucker down in between these caps, but I don't know. I doubt it. That's why I'm taking them off now. Plus, it's a lot faster if you just take them off. Okay, so there's 8 times $3.50 in the trash can. So, yeah, check that out. Now we can get a much better look at it here. Oop, wrong way. Yeah, look at that. Whoop. Come on, focus. Focus. There we go. Man, that thing is toast, isn't it? Look at that. This is just a brown zip tie. Yeah, it got so hot it's peeling the trace off the board. Wow. Yeah, so that's not good. I see the Opto Triac stood up pretty good. I'm gonna have to look at what these things are rated at. Yeah, that probably just it probably just smoked this thing. It must have had a plume of smoke coming out of this thing when it shorted out, because this is, I mean, it's burnt right down into the, you know, FR4 PCB material. Yeah, I bet you that smelled sweet. So one of the things I have to be careful with in replacing this are these pins right here. I can't cut them off. If I cut them off, I won't be able to stick another high voltage board on there. So I'm going to have to solder suck these guys off. And before I do that, I'm going to go ahead and cut out all this silicone, electronics grade RTV silicone. Anyway, I'll be back. I'm going to go ahead and cut this out. You don't really want to watch that. It'll be very boring. Okay, so I'm going to be using my brand new, just got it in the mail the other day, Hako or Hako, however it's pronounced, FR301. See if you can see there. Yeah, there's a model number. FR301 handheld soldering or desoldering iron. Yeah, so setting 1 is 350C, 2 is 400, 3 is 450, and 4 is 500. And I do use lead-free solder, so I'm going to put it on. I'm going to start with number 2, because I usually solder with around 375 for the lead-free solder. And so I'll try sucking it out at 400C. It goes so hot, I'm guessing that these are probably needed, you know, thermal reasons, right? You know, if you're sucking out a big pin that has lead-free solder on it, you might need to crank it up to 3 or 4. But these are fairly small pins. I don't remember the size of them, just regular header type pins. So I'm going to start with number 2. You set it by, let's see, will that thing focus? Probably not. Okay, I'm going to adjust it to number 2. And if you're wondering why I'm not reading the instructions, I'll show you. Hold on. So here are the instructions they sent me. And I don't read Japanese. This thing is made in Japan. And let me zoom out a little bit here. Yeah, so I guess this may be the warranty. I see something about guarantee down there. And I guess this is I'm assuming the manual. Thank goodness it has pictures. Yeah. So there's a desoldering iron. And here's where it shows, and it's got a little button there. Maybe that's calibrating it, maybe? Don't know. Oh yeah, I do see cal. So it's probably for calibrating. It's not a button, it's a little screw right there. I don't know if you can see it. Not that important. And yeah, this is they kind of give you instructions on how to desolder a pin. Kind of stick it on there, touch the pin, and then you kind of jiggle, 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 round, and then you hit the vacuum. And so this is another reason why it might need to be a little hotter than 400C, because as soon as that vacuum starts sucking, I'm sure it cools down in a heartbeat. Anyway, yeah, thank goodness for pictures, right? Here's how the filters and pre-filters work. This is for catching the solder, I'm assuming. I got some cleaning tools, and that's it. Maybe I'll do a review on this thing. It's not that big of a deal. It's actually fairly cheap. It's only like $245 US, which is fairly inexpensive for a Hako anything. And yeah, unfortunately, I would have preferred a real on-off clicky switch instead of one of these soft switches. Oh, it does click. Well, look at that. Okay, excellent. Let's see, do I have it plugged in? Yeah, it should be plugged in. I don't feel it heating up. Oh, yep, it's heating up. It's making noise too. It's heating up and making noise. And hopefully there's no warnings in these instructions like, yeah, for first use you need to break it in and do this and that and the other thing. Because I can't read Japanese. So there you have it. Anyway, I'm going to let it heat up for a second. And we'll give her a shot. I don't know if you guys can see. It looks like there's something in it already. Oh, there we go. It sucked it down. Maybe it had some solder to keep water out of it or something. Who knows? Well, it seems to be hot already. Okay, I'm going to try to do this where everyone can watch. Hopefully my autofocus won't get all boogered up. And I might only do a couple. The ones that are real close here, I might have to get down there and be personal with. And I'll probably have my head in the way of the camera. Let's see, is that... Okay. Wiggle, 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 wiggle. Whoa. That looks pretty good. Let me look at it under the microscope. Here, I'll try to zoom you guys in a little more so you can take a look at it too. Whoa. Come on, autofocus. Oh, okay. Sorry, I moved it around on you because I'm looking through my microscope. All right. I guess that's okay. It looks like I still see a little bit of solder down off in there. Let me see if I can move that pin. Yeah, see, it's still... Let me do that again. Okay, ready? Okay, put it on there, and wiggle, 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 wiggle. Alright, let's take a look at it now. Oh, much better. Mucho better. Excellent. Ooh, wow, I kind of burnt the FR4 though, so I'll have to be careful with that. That 400 degrees is pretty darn hot. Yeah, see, I kept it on there too long and it burned it. You can see right here the FR4 is burnt. And that would be bad if I'm wanting to salvage this thing. Or maybe it's just burning the conformal coating. Yeah, because this FR4 should be rated pretty hot. I think it's just burning the conformal coating. Of course, now that I've scraped it. Let me see here. Yeah, I think it was just burning the conformal coating. All right, so let me try the next one. Let's see, I hope you guys can see this. Let's see. No, that one's not. This one's good. That one. Yeah, still got a couple there. Let me hit it again. Hopefully we won't burn anything. Oh, nice, nice, nice. Very good. Yeah, I have to be careful. I don't want to unsolder it from the bottom more too. Anyway, I'm going to go ahead and do the rest of them. I won't bore you with it. Anyway, I'll be back. Sorry, I was going to show you guys me pulling this thing off, but as soon as I did this last pin, I was holding on to it and it just fell apart. So, yeah, that took 5 minutes, maybe less, to do it. Probably less. I did get a little close to this power supply. I really had no choice. It's unfortunate. So I'll have to. I won't be able to reuse that in a production. And I don't know if I'd reuse this in another production unit anyway, just because, you know, who knows what happened to this board and all the other bad things that could be done. But the good news is this right here should be just fine. This is all isolated. This high voltage board is isolated by these opto-triacs right here. And if you don't know what opto-triac is, it basically decouples the high voltage plane from the low voltage plane with air. It uses lights to transmit the signals, and so yeah, this bottom board should be just fine. You know, as long as we didn't unsolder any of these header pins, but they are these board-to-board connector pins, I should call them. It should be just fine. Here's what the inside of one looks like. Yeah, so I'd have to do that if you sent your controller in, and I had to replace, you know, put a external Wi-Fi guy on this guy. That you're basically looking at the procedure. This is why I suggest you make sure that if you think you might need external Wi-Fi, you get external Wi-Fi. Anyway, that's what it looks like inside there. Yeah, I put a little hot snot in there to make sure that lever never pulls up for the flat flex connector on the LCD. And this, you can see the potting all around. And then we have our little ESP32 guy. I'm gonna have to cut him out. He's glued down there, and I'm sure the conformal coating's probably got him pretty glued down, but I'll do that off camera. It's not very interesting. Anyway, I think that's it. I showed you my Heiko, however it's pronounced. This is a ground decoupling cap, 2.2 kilovolt, and for ESD reasons. And yeah, that's pretty much it. I'll have to sell this as a factory refurb, but yeah, I'll put a new high voltage board on it, put it all back together, and put it out there for sale as a factory refurb. And yeah, anyway, I hope you liked that video. If you do, give it a big thumbs up. If you have any questions or comments, leave them in the comments below, and I'll see you guys next time. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.